Well, welcome back to the Azure Podcast. This is episode number 443, being recorded on the 19th of October, 2022, with special guest Cesar. I'm Sujit, and on Teams with me, we have Cynthia, Evan, and of course, our special guest we're going to get to in just a minute. But before that, let's dive into some of the news from this week. I believe we have quite a few updates, right? I guess is this the follow on from
I
Ignite
say it's
that we're
still
seeing
over
here?
from Ignite still. I think there's a lot still coming out.
Yeah, Evan, I noticed you put a bunch in there, and I've got four as well that I would like to talk
Yeah,
about.
sure. Let me I think most of mine are relatively small and a couple of them will be probably be future episodes. Just sort of running through them. The first one, and I guess I don't know whether I'm shocked or not shocked that AKS has this now, but you can go up to 5,000 nodes in your AKS cluster. Um, that's a big workload. The old one was 1,000. That was a big enough workload. I'm a little bit, my mind's a little bit blown for a 5,000 node cluster. The for SQL Server, you can now do confidential compute VM options underneath it. Again, if you want to have that extra level of security. Um, the Azure Resource Topology service is in public preview. This allows you to look at sort of your network design and how everything is connected. We'll probably see about getting them on the show. Um, the Express Route traffic collector flow logging. So this allows you to see source IP, destination IP, BGP, ASN, everything for your Express Route data in a nice visual perspective. And the last one that we're definitely going to have to do a show on is the Azure Elastic SAN. Is in preview now, and this is literally a virtualized SAN. This is not a bunch of disks that you have to manage. This is just big, massive storage that you don't have to care about the disks. So we'll definitely get a show on that down the road. I've got that on my to-do list.
Awesome. And I've got a few that I can go through real quick. One is about OpenTelemetry, a popular standard for logging these days. And they have this concept of exporters. And now Azure Data Explorer can ingest the OpenTelemetry data directly. So you just configure an exporter in OpenTelemetry to go straight to ADX. And that will allow you to keep all your log data in one place and do queries and whatnot. The other one is the Azure Savings Plan for Compute. This is new, where you can now say, okay, now I'm going to spend, at minimum, I'm going to spend so many hours in the entire year, and you can kind of commit to that that minimum bar, and so they'll give you a much lower rate for that as long as you consume those many hours. If you go over that, you pay the regular rate. So at minimum, you'll save quite a bit of money, and I think that most
Oh, so if you know you're going to spend that, it's actually a sort of a no-brainer at that
exactly.
point.
Yeah,
Hmm,
really. I mean, if you're committed to, hosting on Azure for the next year or even 3 years, they have a plan for 3 years as well. You get even more savings. Just that minimum bar, you could save a lot of money there.
nice.
And then the other one was a networking related one. Evan, sorry,
Stole it.
jumped into
Thief.
your space here. But and the Express Route has this feature now, Express Route Metro. So typically, you can have a single connection. Now you can have two connections going into Azure in the same metro area, and have that scale redundancy or resiliency option in case one of those networks go down. But my absolute favorite update this week is the Azure Monitor Predictive Auto
Saw
Scale
that. That's
for
cool.
for VMSS, right? And this is not just regular auto scale where you have to set the rules. Here, Azure Monitor will predict what the rules should be, and will ahead of time will scale up and scale down for you based on historical captured data. So this is, I think, the best of all worlds, especially the time that it takes to scale up a node can sometimes be non-trivial. And you're getting a burst of traffic. It's taking 15 minutes for the node to come up, and you've already lost 15 minutes of, that time. Now, Azure Monitor will, in advance, will scale up that node for you, knowing that, hey, there's going to be some sort of traffic bump over here. So I think this is phenomenal, and really excited about this one. And those are all the updates I have. Cynthia, was there anything that sprung to your mind?
I have not listened to last week, but have we talked about Azure deployment environments?
No, I pushed that to next week because I actually think we should get a show on that.
Okay, then we will wait until next week.
Okay.
Awesome. Well, let's turn the mic over to our special guest, Cesar. Cesar, thank you so much for joining us today. A very special topic that we'd like to discuss with you, but go ahead and tell us what you do at Microsoft, what your passion is in the Azure space, and we'll take it from there.
Sure. Yeah, so I work for the Azure team, strategic missions and technologies. It's related to the products for the future in Azure, right? My background is also about AI, machine learning. I was a PM in the Azure machine learning team until recently, and also working in DevDev, .NET machine learning, microservices, and so on. But now I'm focusing on the kind of what are the new products related to the cloud and for the future. And one of the areas, and I work for kind of the technical side, one of those areas and products are related to 5G, right? So that's kind of the main topic for this discussion. Yeah.
So I know 5G can be like a very big area of exploration when you have a discussion on it. Um, Help us understand, what Azure is doing in this space, like just at a high level, and then we can drill down to see specific area that you're kind of focusing on.
Yeah. Because that's a like looks like a simple question, but in reality is like the first question anyone can think about, right? Like, hey, Azure's cloud, 5G is networking, what's the relationship, right? And so I'm going to explain that, but also I also want to highlight that it's not just about the networking and the products, it's also about what this is enabling, which is a new kind of set of applications. And so that's another topic that I want to touch today. So think about the cloud. We all know about native cloud native applications, right? And are related to the cloud, like the best applications, microservices architecture, and so on. 5G is also enabling a new set of new applications, what we call modern connected applications, or you could call it also something like edge native applications or native connected applications, right? So that's kind of, as a developer, I could think about. But then why or what's the capacity that 5G is giving? It's what we can also discuss today, right? So talking about 5G, right? Because if you search about, okay, what is 5G providing me, and you search for that in the internet, typically you will find like three pillars, right? That, for instance, one is massive machine type communication, MMTC, which means you can have a lot of devices in small areas or large areas, but the density can be huge, right? Another one is enhanced mobile broadband, right? And that means the bandwidth that you can have with 5G is huge compared to previous wireless like 4G, 3G, right? And finally, the third pillar is ultra reliable, low latency communication. The acronym is URLLC. And that's probably the most important, which is the communications provided by 5G is very reliable with very low latency, right? And probably this is the most important or the most kind of differentiator if you compare, for instance, with Wi-Fi, because Wi-Fi you could also have a lot of devices with Wi-Fi 6, or you can also have a very good bandwidth. But reliability and security, there are a few topics that I will answer later, are differentiator for 5G. But then coming back to the global concept, right? 5G is, at the end of the day, as we were saying, it's a network improvement, but it is a huge network improvement. And the important thing is what it's going to enable. So that's related to new use cases and new scenarios, new applications that were not possible without 5G, right? So that's what I want to chime in later. Like some scenarios in real time, mission critical, large surfaces were not possible previously. And by the way, just one more thing. Anything I'm going to be discussing and explaining, we're going to provide like some content, like infographic and so on. at aka.ms/Azure Podcast 5G. So if you're listening this podcast but you are also have access to the internet, then you can open the infographic and you can kind of look at the visuals while I'm discussing about it. Okay.
They built this infographic just for our audience. So that's the story we're going to go with. Cesar, there's a couple pieces to this, sort of the bigger picture, right? Because Microsoft, we're getting into the basically the operator space, right, which is providing the infrastructure underneath for mobile connectivity. But what you're really talking about is sort of the stuff that sits on top of that is not just a Microsoft piece, right? Like we're certainly shipping infrastructure, and third-party providers will set up their 5G networks on top of our infrastructure, but you're really focused on the applications and the scenarios that you can enable regardless of the technology underneath, or do I have to be on Microsoft's stack to be able to do what you're talking about with 5G?
There are different levels, but you're right. Like I didn't mention that what's Microsoft providing as a product, right? Because there are two things, right? Like I was focusing on what are the benefits and what you can get from 5G. But you're right. If we just talk about 5G, well, it sounds more to me like related to operators. So what's that related to Microsoft, right? So Microsoft is also providing new products related to 5G. Some of those products are, maybe the best way to put it is there are kind of two target customers. One is the enterprise. The other one are operators, right?
Okay.
So maybe let's start with operators because it's kind of the more direct thinking, but probably for our listeners, maybe it's going to be more interesting what's related to the enterprise. But for operators, Microsoft is going to release, because today is still not GA, two products. One is Azure Operator Distributed Services, and kind of the core of that is Azure Operators 5G Core. So what are those products? Basically, Microsoft bought some time ago a platform from AT&T. It was called AT&T Network Cloud for many distributed services for operators. And it's kind of, we are, let's say, Azureizing that, providing all of the great integration with Azure. But at the end of the day, it's also providing like a operator or carrier grade of these core 5G core and many other services related to voice, data, packet core, policies, etc. But when I say it's also Azure, it's like unified or integrated with Azure on things like Azure Arc, DevOps, security. So if I'm an operator, I could take advantage of all those services from Azure for my core software to drive a 5G network as operator, right? That's the summary, right? And then there's the other area, which is completely different or partially different, which is what we are offering for the enterprise, right? So because in the first case, operators is like 5G coming from AT&T, T-Mobile, Verizon, or any other operator, new operator that wants to provide 5G. But there are other scenarios, if I'm an enterprise or any organization or even government, where I might want to create a 5G network private, right?
So this is sort of my own little separate network at that point. Okay.
My own little, maybe it's for a single scenario. Could be, for instance, I want to have, let's say, I have a factory and I want to have like a large factory, large dimensions, and I want to have all my devices or robots that are mission critical. I want to have that connected through 5G. I can create a 5G private network, and I can do it with Microsoft software. So basically, what we are offering, it's a new product. It's now in preview, which is called Azure Private 5G Core, which is the packet core, kind of the brain of the 5G network. So when I say brain, it's like how do you provision the SIM cards, policies, security policies, filtering of protocols, kind of the brain of the 5G network. And that is installed in a local server, in on-premises, and that's why it's private. And then that is integrated or connected to the RAN. RAN means kind of the antennas and kind of the software and hardware more related to the 5G antennas. So this packet core, 5G core for private networks is coming now from Microsoft, and then it's very well integrated with Azure. So you can control with Azure Arc all these servers, devices that are running on premises, but you have the visibility and kind of aggregation from Azure, thanks to Azure Arc and all the assets that we have in the cloud. So, but to sum up, like basically we are offering these 5G products as software for operators or for private companies that you want to create your own private 5G network, right?
I got to talk to somebody. I want one at my house. I have my own little one.
Yeah.
That'd just be cool.
So Cesar, kind of following up on how you mentioned for enterprises, they could have their own private 5G network for a application or their own, how they want to use their edge devices. When they do like a private network, do they just use 5G? Or are these architecture now like using a combination of 5G for certain operations, and then they still use Wi-Fi, for instance, for other operations?
Right. That's a great question, because usually like customers might want to see, okay, so what's better, 5G or Wi-Fi, or is it overlapping? Do I need to decide for one or the other? Basically, the way we see it is they are complementary in many ways, but it really depends on the use case that you have, right? So for some cases, Wi-Fi could be, let's say, enough. In some cases, can be cheaper and could be enough. You have like a Wi-Fi, let's say, in a building, and then internet connectivity, and then devices using Wi-Fi. Might be cheaper than 5G. But for many other scenarios, and this is where you need to think about, okay, what are kind of the clues that can tell me 5G is better for this use case, right? So for instance, things like, hey, for my scenario, my use case, I need to cover a large area. Could be very large buildings, or could be outside, could be a stadium, could be a road, smart city. If you were going to do that with Wi-Fi, even when a Wi-Fi access point is very cheap, maybe the cost would be even higher, because you need to put a lot of those, a lot of connectivity between those access points. Like when you are talking about large dimensions, that's a point for 5G, right? For a 5G network. Like then that's one of the main topics. But then there are other topics even for within buildings. Let's say manufacturing. I have a factory, a large factory that is mission critical, and like I'm maybe connecting mission critical robots between them. And to me, it's super critical that if anything happens, I need to detect that and react with at the second or less, right? And in order for that to happen, you can say, well, Wi-Fi is also very kind of a lot of bandwidth and low latency, but the problem is reliability. You might not have that with Wi-Fi, and you have that with 5G. Why? Because with Wi-Fi, okay, you put Wi-Fi, it's working today on a certain way, but tomorrow, other companies around might be putting additional Wi-Fi access points, and then you are sharing the spectrum, right? And then maybe it's not working the same way tomorrow or in the future, right? You don't have control of all the spectrum that is happening in the air, right? But with 5G, you do have that control, because you need a license for the spectrum, for the 5G spectrum that you're going to use. Then you're kind of reserving that for you, for your use case, and no one else is going to put anything on top of that, right? And in addition to that, you have other things like more advanced than Wi-Fi. And in Wi-Fi, you don't have it, like slicing. You can kind of create different slices of the 5G network, and then you can say, okay, today I just need these slice, but then tomorrow, if I have a spike, I can add more kind of dynamically, right? And Microsoft, that's more for the future, but we might be, we are kind of working on, hey, how can even applications talk to the network with kind of network APIs, so the network can react dynamically to what my application needs, right? So that's kind of science fiction for Wi-Fi, but this is happening, and it's gonna happen for 5G. So reliability and quality of service is key also for 5G. You cannot get the same quality of service, ensure that level in Wi-Fi compared to 5G, right? And finally, also security, the security and policies that you can have, like for instance, using Azure Private 5G Core, it's a lot more kind of advanced and flexible compared to Wi-Fi, right? But then it could be complementary, right? Like you could have like within the same company, part of it maybe you use Wi-Fi because it's perfect for that use case, but then for other area in the company, you might want to use 5G, right? I don't know. Like one example could be, let's say, for trains, right? Rails. One use case could be within the train for the passengers. I want to have great internet. Private 5G won't work because private 5G means that the company is providing the SIM for your phone. That doesn't work for consumers, right? Could be with public network with 5G, but then maybe the density of the stations, the antennas is not enough. So maybe for passengers you can put Wi-Fi, and then maybe connectivity to internet could be through Azure Space and satellites if the train is going through somewhere that doesn't have like public 5G density or good connectivity. So in that case, Wi-Fi and satellite could be enough. But what about the safety and security of the rails? For that, you could have like 5G, because it's very long distances. You can have 5G with cameras and private, kind of detecting what's going on the rail. Is there any issue, accident, with cameras and models, AI models running very close to the cameras with low latency, and then detecting what's happening and sending warnings, right? So you can see that for the same company or same organization, it's complementary as well, right? You can think about other scenarios like stadiums where Wi-Fi, Wi-Fi could be also complementary with 5G, but if you want to, a new stadium and you want to deploy 5G, it's going to be a lot faster because with a smaller number of antennas, you get everything, right? Inside, outside. With Wi-Fi, it might take a lot more work of doing that as well, right? So that's one example, but other examples, smart roads, like I said, manufacturing, mining, like a large mines with, you want to see what's going on, issues, detect anomalies. There are many use cases for that.
It sounds like, when I hear you talk about this, right, this is talking about the different ways to connect and sort of balancing, latency, private, public, all those different pieces. And you mentioned the applications, and some of this is about providing application capabilities like machine learning or AI or whatnot. If I'm an enterprise application developer, do I have to write my app knowing that I'm on 5G or that I'm on Wi-Fi or that I'm on some mix, or is the intent to build it where I'm just going to go connect to an endpoint and then that the infrastructure underneath sort of figures out, hey, you're on a 5G network, so I'm going to use these APIs. Like, do I need to worry about that as an application developer?
Yeah, that's a great question. Because in the almost 100% of the cases, 5G in reality is transparent, right? It's like, as a developer, I'm creating an app. Do I need to be aware if connectivity is going through Wi-Fi or Ethernet? Do I need to know about the configuration about the router or Cisco routers or this access point? Not at all, right? But I'm saying 99% because in some cases that we are working for the future that I mentioned previously, in that case, yes, but it will be kind of for the most critical and kind of top-notch
Some sort
cases,
of
right? That your
niche
application is going to
scenarios.
talk to the
Yeah.
network for huge spikes and react. The network is going to react. But for most of the cases, the developer won't need to be, won't need to do any or to type any special code for 5G, right?
Right. Okay.
But we want to focus on, hey, okay, you don't need to code anything special because it is a 5G network. It's at the end of the day, TCP/IP, HTTP, like regular protocols. Don't worry about it. The only difference is that some devices are going to be 5G, like a camera. 5G camera is going to send all the information through 5G, or any sensor, right? But that's kind of transparent for a developer of an application, right?
Okay.
But where we want to focus a lot is, okay, but what are the benefits or why of 5G that are going to kind of create a new paradigm of applications that were not possible previously? And the main difference is mostly two things. One is bandwidth, although you could have great bandwidth also with cable and Wi-Fi, and latency. But basically, it's kind of the joint between 5G and edge, right? And the edge means that you will put your services of your custom application close to the Wi-Fi network. So because of the low latency, you can react at the second or less about things that are happening. So that's why, like years ago, having a smart road reacting on small things happening, a box drop to the from a truck, or any accident, like reacting, like cameras recording that, sending that high quality, high
It was
resolution
always
video
low
to a
speed
model,
relatively.
and then
Yeah.
that model detecting that and sending that event in super short time. That was not possible
Right.
because of the communications, right? Like you couldn't have like high resolution 4K camera on the road and maybe hundreds or thousands of those cameras sending that 4K video to AI models and then detecting things, because the bandwidth required for that was not possible
Huge.
for
Yeah.
3G or 4G, right? So that's kind of the mindset that we want to highlight. There are many new scenarios where latency is critical, plus large environments, large areas, broad areas are also important, that it was simply not possible in the past to think about those scenarios, right?
Right. So I don't have to change anything from an app perspective. It just enables me to do scenarios
Right.
that I couldn't do.
It's
My code looks the same, basically,
right.
at the end of the day. Okay.
And that's related to what I was talking about at the beginning, right? Because you could say, okay, what kind of applications and services do I need to create? Well, to me, think about cloud native applications as a developer, where key points are microservices architecture, Kubernetes, Docker containers, messaging brokers, publish subscription for messaging, and all those messages can be, information coming from sensors, right? So that kind of architecture, but instead of putting that in the cloud, you would put that on Kubernetes at the edge, right? And when I say at the edge, it can be public MEC or private MEC. I can explain those concepts later, but basically you put that on compute very close to the 5G network. So when you detect you're getting information or video, you do that processing super quickly because of the low latency, and then compute like with AI models detecting things, and then sending those events to the broker, messaging broker, and all the kind of subscribers for the service are going to get that warning, like a dashboard or another machine that needs to be aware, and that can happen in even in milliseconds, right? That's kind of the difference.
Okay. Great.
Yeah, Cesar, I think I have read your book on .NET microservices that you had, I think, previously written, right? Was that you?
Yeah,
Yeah.
I precisely. I
But
wrote a book about .NET .NET microservices like a few years ago when I was in the .NET team as a program manager.
Yeah, I remember that,
And
and most of what I know about microservices I know from that book. So
Oh, now you're sucking
sorry,
up, Saji. Now you're sucking up.
no. I just realized I said, wait a minute, I've heard this Cesar's name before. Where have I heard it? It's
That's
like,
so you
wait
said, wait a minute, when
I-
he's talking about microservices, it's like talking with a lot of passion, right?
and I can see that now where you're going with this architecture here. It's containerized. Your book talked about containerized .NET applications, and of course, this could be anything, but it doesn't have to be .NET. From an
Yeah, of course.
application developer perspective, and that's the reason I read your book is because I'm an app developer, and I'm trying to understand, like, how do I have to think about deployment, right? Like, I'm going to write these microservices. You talked about, you know, Kubernetes or and whatnot, but from an Azure perspective, right? Where am I deploying this, right? What exactly am I doing to make sure that it is close to that endpoint and achieve that low latency? Obviously, I can't run it on in Australia East region because the latency is not going to be low over there. So it has to be deployed somewhere special
Right.
to achieve those low latencies. I'm not getting a good sense for how that would work in this new paradigm that you're
Yeah.
describing.
And that's a great point, because originally when thinking about microservices architecture, you would think about, okay, that's great for large applications, very complex, that need to scale out a lot. So I put that like in Kubernetes clusters in the cloud. If I have a lot of users, I start kind of creating many more instances of the microservices, and I can scale out. And you could think, what does that have to be with what's the relationship with the edge that in many cases could be kind of smaller, right? So it's more a matter of kind of a way to design everything in small components, very light as well. So basically, it's more about performance and light components, and I can deploy kind of my end-to-end application with a light messaging broker, light services, and then I deploy that in a local Kubernetes. And because Kubernetes is not just for scaling out, you think about Kubernetes, you can deploy Kubernetes in Azure Stack Edge appliance or server, but you can even deploy it in other devices that are much smaller, kind of IoT devices with a small process capability. So that's kind of the point, depending on how much power you need. If you are maybe just processing, let's say, telemetry and data, and you don't need to process video with AI models, you could even deploy your solution with microservices, very light Kubernetes in a small device at the edge and react super quickly, right? So that's why it's related to the architecture and microservices and Kubernetes. But you can think about similar designs and architectures that you could do with cloud native in the cloud, very similar but kind of reduced at the edge, but also using the same approaches with Kubernetes. Also, Dapper is a great platform from Microsoft for microservices, right? So yeah, that's a great question.
So you mentioned Azure Arc, I think, earlier, right? So is that something that's going to be hand in hand with the 5G connected application? They would have to use like a Azure Arc to kind of manage that Kubernetes cluster, which is potentially close to the edge.
So basically, what's related to Azure Arc is more about managing the infrastructure. So if I'm a developer of my application and microservices, probably I don't need to deal with that unless I'm also managing the infrastructure. So for instance, when you deploy Kubernetes in a server at the edge, could be an Azure Stack Edge appliance or server, or could be a generic server. Could be also, Dell or HP or any server that you put at the edge, and then you install it's running with HCI and Arc enabled, right? So then Kubernetes is also Arc enabled, and even the Azure Stack Edge, kind of all the infrastructure that you deploy on that machine, you can control that remotely from the cloud. But The important thing here is not just that you can do it remotely from the cloud, because you could say, well, I could connect directly to that server somehow, right? Maybe a VPN or in any way, right? The importance about the cloud is aggregation, because think about, let's say I'm going to think about a use case where for firefighters, for instance, and private network. Imagine each unit or firefighters has a small network, 5G, which is mobile. So there's a fire somewhere remotely, and then they go there with a truck, and that has the antenna, 5G antenna, so has a great connectivity while they are fighting the fire, right? With drones and whatever, they are detecting things, everything being processed super quickly in that area, which is remote. It's in the middle of some place in a forest or whatever, right? But then coming back to Arc and the infrastructure, you could have hundreds of those units, right? So you want to have like aggregation for all the different hardwares and units and 5G, Azure 5G core, the connectivity. So you can have like in the cloud, what we call a single pane of glass for everything that is kind of more granular in those 5G networks, right? So that's why Arc for the infrastructure is very important.
Thank you. I think this has been great. Cesar.
I'm not sure if you have another question, but another point that I wanted to clarify is the difference between, okay, we have 5G, we were talking about 5G coming from operators and 5G, private 5G, right? So that's very much related, kind of one-on-one relationship to 5G public MEC and the 5G private MEC. And what means MEC? MEC precisely means multi-access edge compute. It's like what we were discussing, joining edge compute with the 5G network, right? So the edge is pretty similar. It's compute, but then it's a different concept when we say 5G private MEC or 5G public MEC. When it is 5G private MEC, that compute is something that you install in these machines locally in your own servers, like the firefighters, that can have like a couple of servers. It's kind of, you manage the hardware that is then managed remotely with the cloud when you have connectivity, but you manage the hardware, right, in a private MEC. When it is public MEC, it's a different concept because the network is the operator, let's say AT&T or Verizon, right? And even when you could have your servers, that might have like a very big exception from an operator to, hey, this is my public network and accessing your server in your location. That could be done, but it's not very common. So what we are doing from Microsoft is we are partnering with the operators, and we are creating like a many data centers from Azure for specific cities, right? So, because the important thing here is the latency. If we put small data center in a particular city, and right now we have it, like for instance, in Dallas, Atlanta, and Miami, you could do the same approach of very low latency, my application running in that city, but I don't need to deploy those services in my own servers. I can deploy that in that data center for that city, right? And it is not just if it is closed. The difference also, and that's why there's a partnership between, let's say, AT&T or Verizon and Microsoft, because it's not accessing that data center from 5G through the internet. It's a direct access, right? So it's super low latency. It's like devices, 5G network, and then like a direct connection to that data center provided by Microsoft and, let's say, AT&T or Verizon directly. So latency, you don't go even through the internet. So latency is super short. So that's what is called private public MEC or 5G public MEC, which is like small data centers very close to your devices, but it is like a kind of joining or merging small clouds with the operator for 5G public MEC, right?
And if I may, I know we're kind of running out of time here, but I want to ask you, you mentioned the word latency many times. Can you give us a feeling for how much what is the difference in latency in a 5G connected scenario versus, let's say, a Wi-Fi scenario or something that we'd be typically used to using Azure Cloud?
Yeah. So for instance, latency in a 5G network could be like between 10 and 20 milliseconds, something like that. Could be even less, but that latency is depending on the standard of Wi-Fi could be similar. Like Wi-Fi 6E latency is also very, 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 very small. So that's why when I was talking at the beginning about the three pillars of 5G, kind of the biggest differentiator is the reliability of the 5G network, and also for large areas where it would be super complex to create Wi-Fi, right? But then if you compare that latency with 3G or 4G, it's a lot better, right? But then latency, yeah, it's critical to have compute close to the 5G network. So that's why it's MEC private, very close, or MEC from the operator, also kind of within the same city, right?
Awesome. Thank you so much, Cesar. This has been great. We'll
Something
put
that I want to highlight, but this is more for the future. What we would like to provide in the future in upcoming months is like, hey, as a developer, this is great, but how do I get started? So we are planning on creating like a solution accelerator, with Kubernetes and messaging and kind of all these things that I was mentioning for these scenarios, right? Kind of, if you know the book I wrote about microservices and the related eShop on containers application.
Yep.
Something similar, but for
I was going to say,
the
I'm waiting
edge
for the
and
next
5G.
book on that right now. I was like, when is that coming out?
He's working on it. That's what he's not telling us. He's working on it.
Yeah.
Great. This is awesome. Thanks, Cesar.
Thanks a lot.
Thank you very much.
Thanks all. See ya.